All right, so here's the question here. This is from 8A. It says, suppose a single bacterium is placed in a bottle at 11 a.m. and it grows, and at 11:01 divides into two bacteria. These two bacteria each grow, and at 11:02 divide into four bacteria, which grow, and at 11:03 divide into 8 bacteria, and so on. Now suppose the bacteria continue to double every minute, and the bottle is full at noon, at 12 p.m. How many bacteria are in the bottle at 11:37, and what fraction of the bottle is full at that time? So we've got two questions here, and this type of question you're going to see a similar question in the 8A study guide on page 8, and you'll see like a little a graph visually demonstrating what's happening as the bacteria continue to double. So this is a doubling problem, and for the doubling problem, we're going to use the information they give us in the problem and see what happens. So let me pull up a blank sheet of paper here. And so we are told that at 11:01 it divides into two bacteria. So when I have a doubling problem, it's always 2 is the base, and it's an exponential pattern that it follows. So 1 minute after, you have 2 bacteria. 2 minutes after 11, those 2 bacteria have split, and so you have 4 bacteria. And then 3 minutes after, those 4 bacteria have split, and now there's 8. They split into 8, and so on. So if these split, it would split into 16. So the pattern that is developing here is you take the base of 2 and you raise it to the number of minutes after 11 a.m. And so at 11:37 is what the problem says. So it's going to follow this exponential pattern. At 11:37, then that would be 37 minutes after 11. This is 11:01. This is 11:02. And so all I have to do is figure out how many minutes after 11 it is and use that as my exponent. So it'd be 2 to the 37th power. Now, in the problem, it says to type your answer using exponential notation. So instead of putting this into my calculator and calculating what 2 to the 37th power is, I can just leave it like this. Now, the next part of the problem says what fraction of the bottle is full at that time. And so when we're talking about the fraction of the bottle, it tells us that the bottle is full in the problem. So it's full at 12 o'clock. So it's full at 12 p.m. So that means that let's work backwards here. At 11:59, 1 minute prior, if the bottle is full and we're doubling, so it's full. Let me it's different. So here's my bottle, and it's full at noon. Then that means at 11:59, 1 minute prior, if it doubles, that means that it was half full at 11:59. And then at 11:58, this is half, this is full, I'm going to call it 1, then it would be half of the half, which would be a quarter full. So you see the pattern emerging here. So at 11:57, then it would be half of this, so it would be 1/8 full. So, what's this pattern? So the pattern that I see is 1 over 2 to the exponent. 1 over 2 squared, 1 over 2 cubed. And so what does this exponent represent? This is, think about it, this is 1 minute prior to noon. This is 2 minutes prior to noon. This is 3 minutes prior to noon. So at 4 minutes prior to noon at 11:56, this bottle would be 1/16 full. So it would be like down here. And that is the same as 1 over 2 to the 4th power. So I need to figure out 11:37, how many minutes prior to 12 is that? So I'll take, and I'll say, that is, it will hit noon in 23 minutes. So this is 23 minutes, I'm sorry, prior. So that would be 1 over 2. Let me put in the same column. 1 over 2 to the 23rd power. Now this one does not say to leave an exponential notation. It says type an integer or simplified fraction. So I'm going to calculate what 2 to the 23 power is, 23rd power, and that is this large number, 8,388,608. And then 1 divided by that would be the fraction of the bottle that's full. This is a very small number, 1 divided by this large number on the bottom, but this is the number that would be my answer. So in these type of problems, you need to follow the pattern that's given to you and figure out what it's looking for. So for the doubling, it's going to be 2 to the nth power. And then to figure out how full the bottle is, we're going to do, because we're going to work backwards, we're going to do 1 divided by 2 to the nth power. And the n here is the number of minutes prior to it being full, where the n here was the number of minutes after 11 a.m.